Welcome to Pact Publishing's HTML5 game development video tutorial. The first game we'll create is a simple counting game. Here's what we're going to build. The game requires a player to click on a numbered tile one by one in sequential order. The game is based on the canvas tag using JavaScript logic. By default, the canvas tag doesn't store any drawing state. You can think of it as an array of coloured dots, a bitmap. This is similar to a painting on paper. You draw a rectangle and the shape becomes a part of it. The paper will not know that there is a rectangle there. We have to manage the state of the rectangle by ourselves. We can either do it from scratch or use a third-party library to handle it, such as easel.js. That helps to manage game states and objects. We'll first create a rectangle shape, display the numbers, put them together, make it clickable, and finally add graphics to our game. Now that we've outlined the game and you know what to expect in the upcoming videos, let's get started by setting up your file structure. Now that you've got an idea of what we're going to build, let's discuss managing your game states while using the canvas tag. We'll use easel.js in these videos, a third-party canvas game library that makes things easier. You'll first need to configure your file structure so that all necessary components are in place. The code editor that I'm going to use is Sublime Text 2. It's available on both PC and Mac with a free evaluation copy. I found that its best feature is the multiple cursor editing. However, you can use whatever code editor that you're comfortable with. You'll need a directory where we can put all files necessary for your game project. Let's create one called Count99. Inside your project folder, we need an index.html file as the starting point. Let's also create a CSS directory where we'll put our gaming styling files and name it count99-game.css. You'll then need a JavaScript directory for all your logic files. Currently, we only have a logic file named count99-game.js. Finally, you'll require a vendor directory to place your game library files. The library can be found on easel.js.com. The Create.js suite contains your game library and other utilities, but we're only going to use easel.js in our examples. I've set up the game's basic file skeleton, and these empty files are where we'll add our code. In the next video, we're going to see how to begin writing the game with some HTML and JavaScript. Now that you've got a file skeleton set up, let's start some actual coding in this session. You'll first need to work on the index.html file. We'll start with some simple HTML code, a head and body section. After adding the HTML code, you'll need to include your CSS file inside the head section so that we can add styles at a later stage. Next, add a canvas tag in the body section. You'll also need to allocate an ID, i.e. game-canvas, to the canvas tag so that we can refer to it while using JavaScript. Next, include the JavaScript logic files before the end of the /body tag. You'll have two JavaScript files to include. The first one is the easel.js file from the vendor's directory, and the second is the game logic file named count99-game.js. Let's save the file and move on to the JavaScript file. Inside the count99-game.js file, before adding any code, let's add a namespace to our code. You can do this by creating one global variable. Let's call it C99, which is short form for count99. Next, define the main game class. Let's put this in our C99 variable in order to minimize the variable's global footprint. You can simulate a class structure by putting the related script in a self-invoked anonymous function. In order to set up your game stage, you'll first need to reference the canvas tag and then initialize the easel.js stage with your canvas reference. It's worth noting that the latest easel.js library is part of the Create.js package and uses the Create.js namespace. The game stage is stored in an instance property for subsequent use in other methods. After creating a stage, you'll need to call the stage update method in order to draw updates. This refreshes the canvas view with the latest game state. Finally, you'll need an entry point to start the game logic when the page is loaded. We'll listen to the window.onload event to initialize the game class. Now that the initial preparation and HTML code for the index.html file is complete, and we've added initial logic to our game JavaScript file, let's start creating game objects. In the next video, we'll take a look at how to draw a rectangle shape on the stage with the easel.js shape and graphics function. In the previous video, we've set up an easel.js HTML5 game boilerplate. However, all you have is an empty game stage and no game objects. In this video, we'll use an easel.js shape to draw game objects and add a shape to the game stage. Let's see how. Let's first take a look at how shape works. Easel.js functions similarly to Flash ActionScript. There's a display list and everything added to the list will be drawn on the screen. The stage is a virtual root of the list. We'll keep adding shapes and objects to the stage, and you can further add display objects inside other objects. As long as the parent object is added to the stage, the entire object tree will be drawn and displayed. To begin with, create a new shape under the create.js namespace. You'll then need to make use of the shape's graphics property and drawing methods. The stroke has a default width of 0, but you can modify it with set stroke style. Before we define the path of the shape, call begin stroke in order to define the stroke's color and use begin fill to define the fill color. Both functions take the CSS color string format. Then we define the shape. Let's see this example. We call rect. Optionally, you can call end stroke and end fill after the path definition. If not, it'll be automatically closed each time a new begin fill is called. Next, draw the triangle. It takes 4 parameters in x, y, and the width and height for the dimensions. We specify x and y as 0, 0, so it's placed at the top left position. Finally, we put the shape on the stage by using the addChild method for displaying it. Now, save your work and view it in a browser to see how the rectangle works. Refresh and you'll see a grey-coloured rectangle shape with a black border. Let's put some basic style on the canvas before moving on to the next topic. Switch to the count99-game.css file and add your styles for the canvas. Set the dimension to 480 by 320 pixels and also specify a black border. To wrap up, align it with the centre using a margin. Now, save your files and refresh the browser. As you can see, we have a rectangular area to work in. We've drawn a rectangle shape on the screen by using the graphics drawing methods. Similarly, you'll be able to draw different styles of shapes on the screen. Next, we're going to see how we can put a numbered text on the rectangle shape by creating a tile class with the easel.js text object. We've now got rectangle shapes on the stage. However, we don't yet have any numbers on them. Fortunately, you can use the text object to draw a number inside a rectangle shape. Let's get started. Initially, you'll need to create another class named tile, a self-invoked anonymous function. A tile contains both the rectangle shape and the numbers text. It shares the same feature as a container does, wherein the easel.js container can contain different game objects. Thus, we inherit the tile from the container by using a prototype chain, and then initialize the container in the tile constructor. Next, you'll need to know what number to draw on the tile. Set the tile class to take 1 parameter while it initializes, and you can store the number in an instance property. Instance properties can store the dimension of the tile, and it'll be useful for reference purposes later. In each tile, you'll have 2 objects, a rectangle shape and the number. We'll use the same code from the previous video to draw the shape. Just add it to the tile class. You'll also need to update the dimension parameters with the this.width and this.height properties. However, this time, add the shape to the tile instead of the stage. Next, we'll use the easel.js text object. The text object takes 3 parameters: text string, font style and color. The font style and color string follow the CSS format. Place the text at the center of the rectangle. To do this, set the values of X and Y to half the dimensions values. The text position is at the center now, but you'll also need to align the text content with the center. This can be done using the text align and text baseline properties. Finally, add the text to the tile. By default, the latter added object will cover the earlier added object. Hence, the numbered text is on the top of the rectangle shape. Let's check if the tile class works. Add 1 tile to the stage, then put the tile at a random position. This position can be anywhere inside the canvas. The math.random function returns any floating value between 0 and 1. When you multiply it with the dimensions of the canvas, we get a value between 0 and the width and the height. Since the tile's position is based on the top left point of the rectangle shape, you also need to subtract the tile's dimension in order to prevent the tile from being placed outside the canvas's boundary. Let's save the file and refresh our game. You can now see the tile appear at a random place. In this video, we've prepared the tile class that's used as our core game object while building the game. You'll now be able to create custom game objects by putting several shapes or text together. In the next video, we're going to see how you can use the tile to build your core game logic by adding different tiles on the stage using the mouse clickable action. Welcome back to Pact Publishing's HTML5 game development video tutorial. In this section, we're going to create the core game logic for our counting game. We'll add click handling, destroying the tiles, and displaying a game over scene. Let's get started. Now that you've figured out how to get a tile on the stage, you'll need more tiles in order to make the game playable. A simple for loop can add more tiles on stage and place them at random positions. Let's see how. First, you need to open the count99-game.js logic file from the game's project directory. We already have a tile on stage. In order to clone the tile, wrap the tile code within a for loop. If for the variable I the initial value is 0 and the variable I less than 0, I will increase. Remember to add closing braces or else your code won't work. Save your file and switch to the web browser. Refresh and you should see 10 tiles on the stage which are randomly placed. In order to display incremental numbers on the tiles, use the loop counter I. Now refresh the browser and there you have it. You're now probably wondering about how players will be able to click on the lower denomination tiles if they're under tiles with a higher number. Our gameplay requires a player to click on tiles in ascending order. Fixing this is simple. Just adjust your for loop counter. In order to make sure that the lower value tiles always overlap higher value ones, reverse the loop counter to count down from an upper limit to 1. In this case, from 10 to 1. Then refresh the page, and that should do it. Finally, let's make the total number of tiles a variable. Replace 10 with the variable total tiles. Then assign the number 10 to that variable and declare it before the for loop. We've just used a for loop to add several tiles on the stage, and you'll be able to add different game objects using the same process as well. In the next video, we're going to see how to make the tiles clickable by adding a mouse click event handler. Now that you've got a game stage with numbered tiles, the next step is to add click actions. You can use the easel.js mouse clicking event to handle the clicking logic. Let's see how. You'll first need to set up a mouse press event listener. So let's find the block of code where the tiles are created. Attach a handler function to the mouse press event wherever a tile is created. To begin, define the tile.onPress function as an empty function. The event parameter is useful here as you can use the tile reference through an event.target. Next, the tile will have to be removed after a player clicks it, so let's add the removal logic inside the handler function. You can remove the object by using the removeChild method and remove event.target. Since we've updated the display list, you'll need to tell the stage to update the view. It's worth noting that you ought to be very careful every time this is used in an event handler function. The this here refers to an anonymous function scope instead of the game object scope, so this.stage cannot actually refer to the correct stage reference now. There are two common approaches to working around this scoping issue. The first approach is to reference the game object this to another name, such as that. You can then use that.stage to refer to the stage object scope inside the handler. Let's undo this and we'll take a look at the second approach. The second approach, which we're going to use, is to bind the game object scope to the event handler. You can do this by wrapping the function, call it with a .bind function, then pass the game object scope inside the function. As a result, every time you call this inside the event handler, we're referring to binding this, and it's actually the game object. Note that when using this approach, you can't reference the this event handler anymore. You'll have to make a choice between the reference of an outer scope or the this inside scope. Let's see how this code works. Save your file and switch to the browser. Refresh, and you should now be able to click on a tile to dismiss it. Before we move on, let's do one more thing to optimize our code. As of now, we declare the function inside a for loop. However, it's not good practice to create functions inside a loop. Hence, let's declare this handler function before the loop and call it tileOnPress. You can now simply pass the tileOnPress reference to the onPress handler. Please do not forget the binding. Now, save your file and refresh the browser again to make sure that we've modified the file correctly. In this video, we began with a static game and added a click event, allowing us to delete game objects that are added to the stage. In the next video, we're going to see how you can check if players remove the correct tile by adding a core counting logic to our game. Now that you've got a game where a player can click to remove tiles, our next step is to add some simple logic to make sure that they're only removable in the correct order. Let's see how. Initially, you'll need to keep track of the current count. Prepare a next count instance variable with an initial value 1. Next, limit tile removal to only that tile where the target number is the same as next count. To do so, check if event.target.number is equal to the next count value. Wrap your tile removal code within an if statement so that tiles with the wrong number won't be removed. You then need to increase the next count variable by 1 every time a tile is removed. Now, when you save the file and refresh, you won't be able to click on any invalid tile. In this case, only tile number 1 is valid. Let's add an indicator about the current count for the player. In your HTML file, add a counter by creating a div element after the canvas. Assign an ID HUD to this div element and add a span element with the ID next-count assigned to it. To update the canvas when next count is updated, let's switch to the clicking logic tile and add a line of code to update the HTML after the next count changes. Now save your file and you should see the counting indicator working in the browser. Let's refresh it and check. And the counter works. One thing before we move on. The current code to update the counting indicator is not optional. This line of code is called many times during the game. It would be better if you stored a reference for the next -count label so that we don't have to find it again and again every time a click occurs. To do so, let's extract it as next count label and set it during the initialization stage. Now, let's take a look at our HTML code. Group the game-related elements together by wrapping the canvas and #HUD tag with another div element. Then assign an ID game to it. Next, you'd probably like to put the counter within the game boundary. Let's put it on the top left corner of the game. You can do this by setting the CSS styling of the game and the #HUD tag. Let's switch to the CSS file. For the game, set the width and height to the same dimension as the canvas and then cut the border and margin to the #game element. You'll want these styles to be applied to the entire game element. You'll also need to set a position attribute so that the children elements will have a position based on this #game div. Optionally, you can set the overflow to be hidden so that the game is clipped to the designated dimension. Now for the #HUD tag. Use an absolute position to put it on the top left corner, and let's match the colour of the tile with red text and a light grey background. It would also be nice to have some padding. Let's see how it looks. Save your file and refresh it in the browser. The counter is now placed on the top left side and gets updated when a tile is clicked. In this video, we've added clicking logic and concluded with the counter. You'll now be able to display game status using HTML elements. In the next video, we're going to see how to create a game over scene by adding the logic and transition. You've now got a simple counting game where a player removes tiles sequentially. However, you'll probably find that the counting indicator still runs even though all the tiles are removed. Our next step is to detect if the game is over and cease counting. Let's see how. Initially, you need to add a check where tiles are removed in your code. Every time a tile is removed, the code ought to check if the game is over. To do so, you need to simply check if the counting indicator exceeds the total number of tiles. If it does, call the game over function. We now need to implement a game over function. Define it under the function prototype. Inside the game over function, reset the counting indicator to 1. You'll also need to update the label once the next count variable has changed. You'll have to access the total tiles variable in another method. So put the variable from local scope into an instance variable. Change the var into this.totalTiles and make sure that you update the changes everywhere you use this variable. To make the test easier for now, change the total number of tiles from 10 to 3 as well. OK, let's refresh the page and test our logic. The counting stops at the last number correctly. You now need to display a game over scene to the player, so let's create one. In order to make use of the CSS3 transition effect, we'll build the scene with an HTML div. We'll put it inside the div with an ID #game assigned to it, and then apply styles to the game over scene. Let's switch to the CSS file. It has quite a bit of styling. Let me walk you through it. Set the div to an absolute position inside the #game div, so you can position it easily later. Then, set the position to have 0 left offset. You'll also have a negative top offset that's equal to the negative value of the height of the game. With this value, put the game over scene outside the game boundary so it's not visible until you need it. Since padding counts as part of the height in the box model, we have height and padding added together to match the height of our game. Finally, add some style to the foreground text and background colour. Next, let's define a class that overwrites hiding the game over scene. This is done by setting the top value to 0. As a bonus, we also set a transition to the top value so that the changes will be animated after a duration of 300 milliseconds with an ease out tween effect. You'll need the vendor prefix here because the CSS rule has not been implemented officially by all web browsers. Finally, toggle the game over scene from logic in the JavaScript code by adding it inside the game over function. It finds the Game Over element and applies the class to make it appear on the screen. Now save all your files and test your game in a browser. After you click on the final tile, the game scene is animated from top to centre. In this video, we've taken the counting game logic and concluded with a Game Over scene with transition. You'll now be able to create different scenes of the game and switch between them by the transition effect. In the next video, we're going to see how to restart the game after Game Over scene by adding a restart button using logic. Now that you've got a Game Over screen, your next logical step will be allowing players to restart the game when it's over. You can simply modify the existing code a little bit to restart the game once it's over. Let's see how. Initially, you'll have to clean up the game initialization code so that we'll have a clearer logic separation. Our game constructor has grown into a large block of code. It includes easel.js, stage initialization, counting logic and tile creation. Let's extract the counting logic and tile creation to a new method and name it initGame. After copying the code into initGame, make sure that you call this method, else nothing will be displayed. You then need a button to trigger the restart game logic. Let's switch to the HTML file. You'll have to put an anchor link in the Game Over scene, assign a restart-button ID to the link so that we can refer to it in JavaScript. Now don't worry about the styling, we'll handle it after we've created the game logic. Finally, you'll have to add the logic for whenever the restart link is clicked. Let's do that in the JavaScript file. Add the button listener after you initialize the game. There are two things to do inside the event handler. The first thing is to hide the Game Over scene, and the second is to initialize the game again. Save the file and refresh it in the browser. After clicking on the restart button, you should be able to see the Game Over scene and the game will restart. You'll now be able to restart the game and extract the common game code to be reused in both initialization and restart game scenarios. In the next video, we're going to see how to make your game more attractive by applying graphic assets to game objects. Welcome back to Pact Publishing's HTML5 game development video tutorial. In this section, we're going to polish our counting game. We'll load graphics to the game, integrate a custom web font, and make it work on a mobile device. Let's get started. As of now, you've got a basic working game with a start button, the Game Over scene, and a restart option. However, you'll need some graphics in order to enhance the look of the game and make it presentable. That's easy enough with the Create Easel.js bitmap class. We'll put some graphics into the canvas stage. Let's see how. Initially, you need to draw some graphics for your game. So let's figure out what we'll need to enhance the overall aesthetics of the game. Your core game object is the clickable tile, so let's start with that. The width and height of the tile is 80 by 80 pixels, and here I've used Photoshop to draw the graphics. You'll then need something for the counter as well, so I've prepared something with a dimension of 110 by 32 for it. The background isn't really captivating with a solid colour. Let's design some pattern for it. A simple diagonal line pattern should do. That's all you need for the game scene. Next up, the Game Over scene. For this, you'll need a background image that's 480 by 320 pixels. Last but not least, you'll need a nice restart button. It'll have to be 160 by 67 pixels and composed of two images. The top one is for the normal state and the bottom one is for the active state when it's clicked. We'll use the background position property in CSS to toggle between these two images. All these graphics files ought to be inside the Images folder. Now that we've outlined what graphics are going to be used to spruce up the game, in the next video we're going to see how to integrate them into the canvas by using the Create.js bitmap class. Now that you've got some graphics files, the next step is adding them onto the canvas. You can easily do this using the easel.js bitmap class to draw tile-shaped graphics. Let's see how. Initially, you'll need to replace the grey tile rectangle shape with the new tile graphics. In the tile class, replace the code drawing the rectangle shape with code drawing bitmaps. The bitmap class is under the create.js namespace. It takes one argument that can either be the path of the image file or be a JavaScript image object. Let's put the path here. Don't forget to add the bitmap to the display list with the addChild method. Save your file and test it. You should be able to see the clickable tiles with graphics now. You'll then have to change the graphics of the background and the indicator too. These are HTML elements. Let's switch to the CSS file and find the canvas tag styling rule. Add the background image property with a path to the background PNG file. For the #HUD div, define the background image with a no repeat setting. You also need to adjust the width and height to fit the graphics file. We'll now apply graphics to the game over scene. Since we're going to have graphics in our div element with the #GameOver replace the content of the #GameOver scene with the restart button. Let's delete the existing text in the HTML file with the #GameOver. The background of the div element with the GameOver is simply a background image property. For the restart button, place it at the centre of the scene by using the margin and display property. Then set the dimension to fit the graphic file. After the restart button is clicked, it gets activated. In the active state, offset the background position by -67 pixels. Remember that the restart button graphic is composed of two images, one at the top and one at the bottom. This will toggle them so that the bottom image is displayed. In this video, we've integrated our graphics files into the game by the create.js bitmap and CSS properties. You'll now be able to put the graphics into any canvas stage. In the next video, we're going to create a preloading mechanism and examine how to set your game to wait for graphics to load before starting. You've now got a game with better graphics. However, a slow internet connection would mean your graphics need time to load, and your game isn't playable until the tile graphics are loaded. To tackle this, we'll use a preloader to wait till all graphics are loaded before the game starts. Let's see how. We've loaded the tile graphics file in JavaScript, but you need to know exactly when it's actually loaded. This can be done with the preloader class. The constructor takes the game reference and puts it into an instance variable. You then have another method named loadGraphics under the prototype chain, inside which we create a new image object. You'll need to declare an onload event handler before we set the source path of the image object. This prevents the image from being loaded immediately, and the onload event is fired before we define the method. Next, call the initGame method inside the onload event handler. Thereafter, set the source path of the tile image. The browser will begin to load the image file once we set the source property. You'll also need to set a reference to the image in our game scope, -C99, so that we can refer to it in the bitmap creation logic. You'll also need to set a reference to the image in our game scope, C99, so that we can refer to it in the bitmap creation logic. In the bitmap creation logic, make sure that you set the tile.png path to the loaded image object. We will replace the early game setup logic with the preloader. After setting up the easel.js stage, preload the graphics and then initialize the game after loading is completed. This is a basic preloading technique that works for just one image. Let's see how we can refactor the code to load a list of files. To do this, you'll need a list of the names and paths for the graphics files. We need the name to identify the loaded image's data later. You then need to keep track of how many files are loaded with these variables. We can now wrap our image loading code with a for loop. With each iteration, you extract an image's information from the list and load it via the code. Inside the onload event handler, we track the amount of loaded files and the game only initializes after all files are loaded. You'll then have to replace the graphics path with the path information from the image list. Move the C99 graphics object above the for loop in the code. Also, put the graphics.tile assignment inside the loop. Next, put each image into your game scope with the name defined from the list. Because we store the image path and name instead of the image data in the game scope, you need to change the tile bitmap creation from graphics.tile to graphics.tile.path. Finally, let's give a final touch to the loading. We'll tell the player that the game is loading, so we'll display loading in the counter space. In index.html, set the default value of the next dash count to loading. Hence, when the game is loaded, we set the next dash count label to the initial value 1, as specified in the count99 game constructor. You can copy the line from the tile onPress event handler. To test our preloader, I'm using Sloppy, a Java app that simulates a slow internet connection. As you can see, the loading screen disappears once all the graphics are loaded and the game is ready to play. You'll now be able to add a preloading mechanism for your pages. In the next video, we'll see how to match our text style to the game's pixel art graphics by adding a custom web font. You've built a decent counting game by now with some pretty slick graphics. However, the font face that we're using doesn't really match the game's bitmap graphic style. To tackle this, you can use a custom web font to change your game's text style. Let's see how. You'll first have to find a suitable bitmap font for the text. The internet is your best bet to find diverse web fonts. There are several online services that provide web font solutions such as Google Font, Typekit, FontDeck and so on. Although these services are pretty handy, we'll use another resource and make the web font files ourselves. I've used a bitmap font designer by a Japanese designer, which is free for personal and commercial use. Let's download this TrueType font file. We'll use the web font named Tempesta Compressed Bold. You then need to convert the font file to a web-ready format. So we'll further process this font file. FontSquirrel.com provides a service to upload a font and convert it into a web font. We'll need to add the font to the queue. Choose the default option. Remember, you need to acknowledge that you have the right to use this font on the web. This is important because usage licenses for some fonts may not cover use on your own web page. Once the web font is ready, you'll get a package of files with the converted font and a sample HTML document that demonstrates how you can use the font. You'll then need to add these files to our project. Copy the generated font files and CSS files to the CSS folder. In order to use this, you first need to include the font file in the HTML document with a link tag. You'll then need to modify your JavaScript code, where we draw the counting tile in order to make use of the font. While creating the number text, specify a font family there. Every web font comes with a name, so according to the generated CSS file of the font, our web font is named pf_tempesta_7_compressed_bd. You have to replace the font name there. Finally, add a style to the counter. Open the game's CSS file and set the font family to the web font. Save your files and refresh the game in a web browser. The game now has a bitmap font that fits our pixel art style. Since the font family is changed, we also need to adjust the text padding. Change it in the #HUD div element. Refresh your page again, and the HUD looks good now. In this video, we've added a text style that matches our game's pixel art style by using a custom web font. You'll now be able to define and match a game's mood and graphic style by using the custom web fonts. In the next video, we're going to see how to make the game work on a mobile device by adding touchscreen support. You've now got a complete game, although it won't function on a mobile device. Fortunately, you can easily add touch event handling and perform several tweaks to make the game work on mobile devices. Let's see how. Your first step is handling touch events, something Easel.js can help with. You can add it to the code where we've set up the stage. You can configure Easel.js to enable touch handling by calling the touch.enable method with the stage argument. Save your files and test it in a browser. This time we'll test the game directly on a mobile operating system. In this case, I'll use an iOS simulator. It comes along with the Xcode development bundle from the Mac App Store. If an iOS simulator is not available, you can use an Android simulator or any mobile device to test the game. Open the localhost game URL in mobile Safari and let's test whether the tiles can be removed by touching them correctly. You've probably realised that the canvas stage is too small to play. We'll need to add one meta tag configuration in the game's HTML code to fix this. By default, mobile Safari loads a web page with the width of the desktop browser. The viewport meta tag tells mobile Safari to set the viewport to the device's width. As a result, HTML elements will be displayed at 100 percentile size. Make sure you don't need any default margin and padding space in the HTML and body tags. You can do so by setting it in the CSS file. Let's save our changes and check the page in the simulator. This time the game is displayed with the full device width and height. Our game has dimensions of 480 by 320, so it fits perfectly the landscape iPhone screen. We've adapted the Count99 game to a mobile device by adding touch events and a little tweaking. You'll now be able to create touch-based HTML5 games and run them on both desktop and mobile browsers. In the next section, we're going to see how to create a more complicated platform game. Welcome back to Pact Publishing's HTML5 game development video tutorial. In this section, we're going to develop a new game where a player controls a character running on a platform or jumping between these platforms while avoiding obstacles. We're going to put different kinds of game objects together on the stage, and they'll have collision detection feature. So let's kickstart this section. You've built a simple counting game up until now, straightforward with just a tile game object. We haven't discussed how to handle multiple game objects in one game. Fortunately, it's as simple as using class inheritance to build a game with many game objects. Let's see how. First up, you'll need to plan how your game will function. Let's create a simple side-scroller running game, where the hero keeps running towards the right side, and the player has to control the hero so that he can jump over the obstacles. Here's what our final game will look like. The game uses mouse clicks to control jumping. There are obstacles and gaps between platforms that the hero needs to jump over. We'll also keep score with coins that a player collects as the game progresses. Let's call this game Rush. We'll kickstart developing this game by creating a new project directory and file skeleton. This game will have a file structure similar to the Count99 game we've already built. You'll need an index.html file, a CSS folder with game style files inside it, a JavaScript folder to place your game logic, and a vendor directory for external third-party files. Since this game is more complicated, you'll need separate JavaScript files for each module. We'll use a file named game.js as the entry point. It simply initializes the core game class after the page is loaded. Then we'll have a game class to handle all the game logic. It initializes the Easel.js library with the stage, places game objects into the game, as well as handles collisions and movements. Since we have separate JavaScript files, we'll need to include all these files in the index.html. Now that we've figured out how to start building the game and created the appropriate file skeleton, In the next video, we're going to see how to group code common to different game objects by defining a game object class. Now that you've prepared a skeleton for the game with an entry point, we can start adding game objects. However, you've probably figured that we'll need different kinds of game objects in this game as opposed to just the one that we needed in the previous one. For example, we have a hero character that a player controls, and we have a platform for the hero to stand on. We'll also have obstacles and coins. Let's take a look at what we need to remember for these game objects. They're placed on the stage with the position and dimension. We will need to distinguish amongst them so that you know whether the hero is colliding with an obstacle or a coin. You'll also need to present them visually with either shape or image graphics. Although these game objects share the same common properties, it's not good to have these properties appear for every kind of game object. Fortunately, you can extract common logic into a generic class named GameObject, and all other kinds of game objects are inherited from this generic class. Let's see how. Initially, you'll need to create a new file for this GameObject class. So let's create a new empty file named rush-gameobject.js. Inside the file, we have a basic class definition. We'll then draw bitmaps and put shapes inside it. So we'll inherit this class from the container by setting the prototype to be a container instance. If you take a look at the easel.js source code, you'll see that every class has its own initialize method. We better not override it and break its functionality. You have to ensure that the code is initialized in both the classes, that is, in this class and also in the superclass. So we'll reference the container's initialize method with another name, that is container_initialize. Now we're safe to declare our initialize method without worrying about the superclass overriding it. Inside your initialize method, we will call the superclass. We will then call the initialize method from the constructor. Now that we have inheritance set up, you can add the game object initialize logic now. We have several common properties that you can add to the game object class. Initially, you'll need to know the kind of game object, so we'll use a string to represent it. By default, it's just a normal object, so we can give it an object string. Then we have dimensions for the game object. By default, their value is 0. The X and Y positions are already inherited from the create.js container class, so you don't need to redefine it here. The next step is to separate each module into its own JavaScript file. Remember to always include the JavaScript file in the index.html document every time you create a new file. Let's save the files and open the index.html file in a web browser. The stage is empty, and we'll make sure that there's no JavaScript error appearing on the console. We've taken the easel.js game boilerplate and ended with a generic class that will be used on every game object in this game. You'll now be able to define an abstract class with common properties. In the next video, we're going to use our game object class to create a platform object. By now, you've got a game object class that's just a definition, and we haven't created any specific object for our game. In this video, we'll use our game object class to create a platform that the hero will stand on. Let's see how. Initially, you'll need a dedicated file for the logic and properties of the platform. So let's create a new file and name it rush-platform.js. Then define this platform object as a kind of game object by creating a game object instance on the platform prototype. We have two properties in the game object, category and dimension. Next, distinguish this game object as a platform category. We'll define the dimension of a platform, so let's set it in the initialize method with a width value as 120 and the height value as 12. These values are just an estimation, and you can adjust these values later when we put the game objects together. We'll then represent the platform with a rectangle shape. We'll add graphics to it later, but for now, let's have a simple shape. You'll be drawing a lot of rectangle shapes in this game, so it's good to place code that draws a common shape in a single place. Let's create a new file and name it rush-common-shapes.js. There's quite a bit of code. Let me walk you through it. First, we ensure that the global namespace rush is defined. Then we define a class method named rectangle. This method takes one object argument with the parameters to draw the shape. You'll need several parameters to draw a rectangle shape, including the width, height, stroke style, and fill color. It's tempting to define the parameters as function arguments. However, these arguments require the order of the parameters to match, and it's not easy to ignore some arguments in the middle. Hence, we'll not use that method. In our example, we'll take an object argument and correspondingly we'll get the stroke thickness, stroke colour, fill colour, x, y, width and height parameters with a default value when the property is not defined by the object. We then have the shape drawing logic. This logic has the same code we used to draw the rectangle shape in the last game, the create.js shape. We set the stroke style if we need a stroke and also the filling option and draw rectangle. At last, the shape we drew is returned. We now want to use our drawing code. So let's draw a black rectangle to represent the platform inside the platform class. We call the rush.commonshapes.rectangle method along with the width and height. The default filling colour is black and the stroke thickness is 0. Then add it to the platform container. Next, to make the width property a variable to pass a value to it on creation, let's add a width argument to the initialize method and constructor. Note that we keep the default value of the width as 120 if the width argument is missing on creation. Finally, we want to test our newly created platform class, so let's create a platform and put it on stage. Before testing our game, you'll want to include the new JavaScript files in the HTML document. Now save all your files and test it in a browser. You'll see a black platform on the stage. We've taken the game object class and concluded with a platform object definition. You'll now be able to define a new category of game objects and use a shape to represent it on stage. In the next video, we're going to see how we can define a movable game object that inherits the static game object. You've now got a platform class which is a static game object on the stage. In this video, we will define a hero object using a similar approach. The hero is a character that is controlled by the player. However, you'll probably find that the hero object is something that moves instead of being placed statically on stage. What makes a hero different from the platform is the ability to move. The hero will be able to run on platforms, jump up and fall due to gravity. While developing a game, you could have other movable objects that can move around and are affected by gravity as well. To make something movable, you'll need logic for things like velocity, jumping, falling with gravity. Movable objects share these characteristics, but they're seldom part of the static game object. You can easily define a movable object, that is, a type of our static game object, with extra code to make it movable. Let's see how. You'll first need a movable class. Let's create it. And we'll have a dedicated file named rush-movable-gameobjects.js for it. Inside the file, define the class to be inherited from GameObject. We'll use the same approach to inheritance that creates a new GameObject instance with the prototype property and executes the super-initialize method. Let's put the movable code here later when we handle the moving logic. For now, define your hero class to be inherited from this movable GameObject. Similarly, we have another file named rush-hero.js for logic dedicated to the hero, and a similar class definition that inherits the movable game object class. set the category property to the string hero and then set the dimension to 10 by 16. You'll also have to represent the hero visually, so draw a rectangle shape with fill colour green. We then need this hero to stand on the platform. It will be difficult to calculate the position when the hero moves because by default the reference point of the position is placed to the top left position on the screen. You'll need to take the width and height into calculation if the reference point is at that corner. We'll configure the centre point at the bottom as a reference point. The bottom point allows you to get rid of height in future calculations. The centre point makes it easy for us to have equal calculation on both the left and right side. Then add the hero to the stage to see how your code works. Let's switch to rush-game.js and create a hero that stands on the platform with the Y position, which is the same as the platforms. Before testing your code in a browser, make sure that you include the newly created JS files in the index.html document. Otherwise, the browser will not load your new code. Now, save your files and open the game in a browser, and you should see a green hero standing on the black platform. We've taken the GameObject class and ended with a movable GameObject and hero class definition. You'll now be able to create both static and movable objects. In the next video, we're going to put the platforms together and make the game ready for playing. You've now got a hero and platform. The next logical step is add more platforms. In this video, we'll use a simple algorithm to continuously add platforms that the hero can run on later. Let's see how. Initially, we're going to create platforms one at a time. We'll also have to keep track of the position where your last platform was created. You'll need two variables, last platform X and last platform Y, to store this information. These variables also serve as the first position. We'll then use a for loop to create a lot of platforms. For each platform, we set the X position to be last platform X. For the Y position, it's not at all challenging if we place them all with the same value of the last Y position. The hero will be able to jump, so we can increase the difficulty by introducing some height differences. We do this by adding a random value to the last Y position. Set the Y position based on the last value and the range from -40 to +40. You'll then need to solve a problem introduced by random platform placement. Each platform will now be either higher than, level with, or lower than the previous platform. And the randomness of it limits our control over where they'll be placed. New platforms may be too high or too low, and could also be created beyond your screen. You need to make sure that every platform is placed in a visible position, and we'll do this by using a minimum and maximum function. The first minimum limits the lower bound value, and the result passes to the maximum method for the upper bound value. We'll then create some gaps in the X dimension so that the hero has to jump from one platform to another. You can do this by adding a random X value to last position X. Thereafter, we'll put our hero at the beginning of the first platform. Let's save the files and check our progress by opening the index.html file in the web browser. You can see that some platforms are randomly placed on the stage. In this video, we've taken the game object and concluded it with well-designed platforms placed on the stage. You'll now be able to create running and jumping game levels with a random value. In the next video, we'll add collision logic so that the hero can stand on a platform without falling. Welcome back to Pact Publishing's HTML5 game development video tutorial. In this section, we're going to handle the collision of game objects. We need to detect a collision between the player and the platform so that the hero can run on it and jump over the platform. we're going to add other types of game objects. There'll be obstacles that the player needs to avoid hitting and game coins that he can collect as a reward. Also, we'll need to detect if this hero is hitting the obstacles or collecting the game coins in front of him. So let's kickstart this section. Now we've defined these game objects, however we haven't detected if the two objects on stage collide with each other. This is critical information because we depend on this to make the hero run on platforms, get coins and die on hitting obstacles. Thankfully, we can use a simple rectangle to point collision checking in this game. Let's see how. Initially, we have to find a suitable collision detection approach for our game. Since every game object has its bounding box with x-y position and width and height dimensions, a straightforward approach is to check if any two bounding boxes collide together. However, in this game, most of the collision happens between the hero and other game objects. We don't need to detect the whole bounding box to know if the hero is standing on the platform. We'll use a simpler method that detects only if a given point is inside a rectangular bounding box. This point is the bottom centre position of the hero. We know if the hero is standing on another game object when this bottom centre point is inside the game object's bounding box. In some cases, we may need more than one collision point, so we'll use an array to store it and name it collision points inside the hero class. Then we'll create a collision detection between the platform and the hero, so we'll write the logic after we create the platform and hero. We have a for loop to loop all the game objects and select only the platform category. Before we perform the checking logic, we need to take a look at the easel.js coordinate space. In easel.js there are two kinds of coordinate spaces, a global coordinate space and a local one. The global space means the coordinate is the same as the stage, with 0x and 0y to the top left corner of the canvas. Local coordinate is the coordinate space for each container or game object in our game example. Take hero as an example. The 0x and 0y of the local coordinate is to the top left corner of the hero. It's independent of the global coordinate. The hero's 0x and 0y local point is still 0 no matter how we place the hero on the stage. So, for each found platform, we have to check whether the hero's collision point is inside the bounding box. The hero's collision points are defined in the hero's coordinate space. In order to compare the point with the bounding box, we need to transform the collision points from the hero's local coordinate space to the platform's local coordinate space. We can do that by using the local-to-local method. Finally, we can check if the point is inside the bounding box of the current platform to know if the hero is standing on it. We want to see if our collision logic works, so we'll create a platform with the position overlapping the hero. Then, we save all the files and open the game in the web browser. We should see the console telling us that the hero hits the platform. Then, we'll move the platform away from the hero, so we'll modify our testing platform's Y position to a larger number. Now save the file and refresh our game. There's no collision detection this time between the platform and the hero. We've taken the game level and concluded with a collision detection between the hero and the platform. Now you'll know how to detect if a hero is standing on another game object. Next, we're going to see how we can create obstacles, which is a new kind of object, and the player needs to avoid hitting these objects. So far, you've been able to detect collisions between the platform and the hero if the hero is standing on any of the platforms. However, you may probably find that the game is a little bit boring with only platforms. Thankfully, we can create some obstacles, which will be a new kind of game object, and the player needs to avoid hitting them. Let's see how. Initially, we will define a new kind of game object. So let's create a new file and name it rush-obstacle.js. It's a class that extends our game object class. Find the category as obstacle and set the dimension to 40 by 20. Then use a red rectangular shape to represent it. We'll have to place the obstacle on the platform. To make our calculations easier, we'll configure the registration point to the bottom centre, just like our hero class definition, then add it to the game. It'll be placed on the platforms and will appear randomly so that players will not know where the obstacles could show up. Thus, we'll add an obstacle after every platform is created. You can also use a random value to determine if an obstacle should be added to a platform or not. We don't need an obstacle on the first platform, so let's set an I is greater than or equal to 1 condition. Add the obstacle in the middle of the platform so that your hero has enough time to jump over it. Next, include the new obstacle JavaScript files in the game by adding it to your index.html file. Finally, we want to see how the new obstacles look, so we'll save the files and open the game in the browser. Refresh the game several times and you'll see red obstacles appearing randomly. In this video, we've added platform collision code as well as a new kind of game object. You'll now be able to define a new kind of obstacle game object and place it on your platforms. In the next video, we're going to see how we can add collision between the obstacles and the hero. So far, you've added some obstacles to your platforms. However, you'll probably find that the hero can run into obstacles without suffering any consequences. This is because we haven't added any collision detection between the obstacles and the hero. Our next step is to detect whether the hero collides with the obstacle using an approach similar to what we use between the platform and the hero. Let's see how. You'll first need to add one more collision point to the hero. The current collision point is bottom centre. Since the hero is always running towards the right, we'll need to add one more collision point to the right hand in order to detect collisions between the hero and obstacles. Next, add detection logic by switching to the rush-game.js file. Add the code after the platform-hero detection logic. We'll loop through all the game objects and select only the obstacle category. Now there are more than one collision points on the hero, so loop through each collision point and transform it to the obstacle's local coordinate space. Then check whether the hero's collision point is within the obstacle's bounding box. At this stage, we'll print a sentence on the console when the collision is detected. Finally, create a test obstacle to test the logic. We'll use a test object that's placed near the hero with some overlap. Now save your files and open the game in a browser. You'll see from the console that a collision occurred. Then we move the obstacle away from the hero and we do not find any collision this time in the web browser. In this video, we've added a system that detects collisions between obstacles and the hero. You'll now be able to detect whether your hero is hitting another game object that's in his path. In the next video, we're going to take a look at refactoring your collision detection code into a generic collision function in order to make it easier to reuse. We've got the platform and logic to deal with collision setup. You'll probably notice that these two blocks of code have a similar logic. You can use the same code for both by refactoring it into a generic function. Let's see how. Initially, you'll need to compare the obstacle's coordinates to the bounding box of your game object. So let's move that check to a new method called hitPoint inside the GameObject class. Then in the rush-game.js file, we need a generic method to detect collisions between the hero and a given category of the game object. Let's define a new method named GameObjectHitHero with the category argument. The callback argument is used to call the given function if any collision is detected. Inside the method, we have code that's very similar to our previous detection logic. Loop through all of the game objects and perform checks only when your category matches the given one. Then loop through the hero's collision points and transform the point into the local coordinate space. Finally, check if the game object hits the hero's collision point. If it does, call the given callback function. You can then rewrite our previous code and make use of the new method. For platform and hero detection, replace it with one line that calls our callback function to print a sentence to the console. Similarly, replace the obstacle and hero collision code with the obstacle category method and callback function in case of a collision. Next, group the collision detections by moving the code into a new method named resolve collision and call this method on the init game method. Finally, check your logic code again by adding a test platform and obstacle on the stage that overlaps the hero. The console indicates that a collision was detected between the hero and the obstacle. In this video, we've streamlined our collision code with a cleaner approach using the new collision method. You'll now be able to easily detect collisions between the hero and any kind of game object. In the next video, we'll see how to make use of the new collision method in order to create a new kind of game object that lets our hero collect those objects as a reward. By now, you've got a collision detection logic that works well with obstacles and platforms. Our next step is enabling players to collect coins during their game as a reward mechanism. Let's see how. We'll start off with a new kind of game object. So let's create a fresh file for it. Name the file rush-coin.js. It's another class that extends the static game object class. The category is coin and the dimensions are 10 by 10. Similarly, it's located bottom center because we're going to place it on the platform. Let's use a yellow rectangle to represent it before we add graphics. Then decide where to place the coins in the game. There may be obstacles on some platforms, so we'll have to place the coins only on those platforms without obstacles. When platforms and obstacles are created, we'll place coins in the middle of the platform only if there's no obstacle there already. We'll then add collision detection between the coins and the hero. It's as simple as calling the collision method again with the category set to coin. Let's test the coin collision code. Create one more test coin object to overlap the hero. Finally, you'll need to include the rush-coin.js file in the index.html document to make it work. Save your files and open the game in a browser. You'll see some yellow game coins on the platforms, and we have one test game coin near the hero with our collision detection working fine. In this video, we've used the collision detection logic with a new kind of game object to give rewards to the player. You'll now be able to manage different kinds of game objects together and have separate collision logic for each of them. In the next video, we're going to make the game dynamic and our hero run using the create.js ticker interval class. Welcome back to Pact Publishing's HTML5 game development video tutorial. In this section, we're going to use a ticker interval to make the hero move, and we'll create a camera to follow the hero's movement. We'll also apply logic to the collision between the hero and other game objects. Let's kickstart this section. For now, we've got a game stage with the game object's definition and collision detection set up. The next step is to make your hero run. This kind of game usually has a time interval when the game loop logic executes periodically. We'll need to apply gravity and a running speed to the hero, and also need to move the camera so that it follows the hero. Additionally, you'll need to check for collisions continuously. Although you could do this by setting up different time intervals for each component, it may slow the game with the multiple timer invocation overhead. Thankfully, easel.js provides us with a ticker function, which can be used in an interval to invoke different looping logics on each component. Let's see how. Initially, you need to give the game a heartbeat to execute our game loop, so we'll use the ticker class method to set the frame per second of the game to 40. We then want a game loop function, so we tell the ticker that this game class is set to a 40 frames per second interval using the ticker.addListener method. The second argument makes this game loop pause when the ticker pauses. Then we need a method called tick for the ticker to invoke it. So we'll define the tick method and we update the stage inside the method and perform collision detection. Then we'll make our movable game object fall with gravity. So let's switch to the rush-movable-gameobject.js file to add the movement logic. For a moving object, we'll need to remember the velocity in x and y axis. We also have a dropping speed, which by default is 1. We also would like to know if the game object is standing on something, so we have an on-ground boolean for it. Then we tell the ticker that the movable game object is interested in the interval loop. You need to define the tick function every time you add the object to the ticker's listener, so we'll define a tick function. Inside the tick function, apply the drop speed of the y-axis of velocity. Since the velocity increases with every frame, we have to make sure that the velocity is not too high by setting a maximum value. This method only defines the velocity. We'll move the game object in the main game loop. So let's switch back to the rush-game.js file and delete the testing game objects that we used in the last section. You'll then need a method dedicated to moving objects. So let's define a new method named moveGameObjects. Inside it, we loop through all the game objects and select only those with velocity, and then apply the velocity to the position. We need to call moveGameObjects in the tick method, so it's called in every frame. Now, let's save all the files and test the game in the browser. You should see the hero falling to the bottom from the initial value. We've taken the static game and ended with our hero falling with gravity. You'll now be able to use velocity for your moving game objects and reflect the velocity on the specific position. In the next video, we're going to make the hero stand on the platform by taking the velocity into calculation when the hero hits the platform. You've now got the hero falling on the game stage, but the hero should fall on the platform instead of going through it. Fortunately, we can make use of the collision checking logic and velocity to make him stand on the platform. Let's see how. Initially, you'll need to plan the process to make the hero stand on the platform, so let's take a look at how the hero falls. In each frame, the hero's Y position increases by velocity. When the hero hits the platform, there may be a y-axis difference between the bottom centre point of the hero and the top edge of the platform. We need to know the reference of the collision point in order to calculate this difference. Let's put the collision point in the callback function argument. Then we'll perform the calculation logic, so we'll update the collision logic between the platform and the hero. Let's add the point argument. The distance is the difference between the top edge of the platform and the collision point. The top edge has local y position as 0, so the difference is the negative value of the point y. When the hero is falling, we undo the last movement by adjusting the y position with the distance. Then reset the hero's velocity and we'll mark the on-ground flag as true. Thereafter, we reset this on-ground flag to false before performing the collision checking. We used the hero inside the callback function scope, so you'll need to bind the this flag to the game class. Let's save the files and open our game in the browser. The green hero should fall from the initial position and stop when he hits the platform. We've taken the hero falling logic and concluded with the hero standing on the platform. You'll now be able to make falling objects stop on specific types of objects. In the next video, we're going to apply the running speed to the hero and create a camera to follow him. You've now got the hero falling on the platform, but we need to make the hero running towards the right direction. To do so, you can just override the falling velocity in the hero class to make it run. Let's see how. You'll initially want to set a running speed for the hero, so let's create a tick method in the hero class with the velocity x set to 3. If you save the file and test it in the browser now, you'll see the green hero moving to the right, but gravity doesn't work. This is because we've performed an override on the movable GameObject's tick method that controls the gravity. You can retain the gravity by creating a reference to the tick method before defining the heroes method, and we can invoke it at the beginning of the new tick method. This time the hero has both attributes, gravity as well as running speed. We then want to follow the hero's movement to prevent him from running off screen. So we're going to create a camera container. The camera is actually a container that replaces the stage to store all the game objects. Instead of adding the game objects to the stage's children list, we add them into the camera. Finally, you need to move the camera according to the hero's velocity. So we'll create a new method called moveCamera and move the camera's X position with the same value as the hero's X velocity, but in the opposite direction. We'll then invoke this method in the tick loop. Save your files and test the game in a browser. You'll see the green hero running and falling, and he'll not go out of the screen unless he falls off a platform. We've taken the hero's falling logic and concluded with a hero running on the platforms with a camera in tow. In the next video, we're going to let the hero collect the coins with collision, and we'll let the hero die and restart the game when he hits the obstacles. You've now got the hero running on platforms, but he can't jump to other platforms. Thankfully, we can make the hero jump by applying negative y velocity. Let's see how. Initially, we'll provide our hero with the ability to jump. So let's define a jump method on the hero class. In order to make the hero jump, simply apply a negative y velocity. We'll only allow the jumping activity when the hero is standing on the platform. Let's also read mouse input to make the hero jump. We'll listen to the mouse press event after the hero spawns. You'll probably want to let the player click anywhere in the game to jump, so let's link the mouse press event to this stage. Save your files and test the jumping logic in a browser. You should be able to click anywhere on the stage and make the hero jump from one platform to the other. We've taken the running and movement logic and concluded with the jumping action. Hence, you'll be able to create different actions on the game object by adding impulse velocity. In the next video, we're going to reward the player with collectible coins and end the game when the hero hits the obstacles. We've now got the hero running and jumping on platforms, but the game does nothing when he collides with coins or the obstacles. Fortunately, adding the collision logic to the coins and obstacles in this game setup is simple. Let's see how. You'll first want to remove the game coins when the hero collects them, so we need to reference the coin in the collection checking method. Let's add a second argument to the collection callback as the game object. Then, when the hero hits the coin, we'll remove the game object. Let's update the collision logic between the hero and the coins. We add the coin reference to the callback function argument, and we'll remove the coins from the stage when the hero hits them. We use the this hero inside the callback function, so you'll need to bind the this property in the game class. To keep score, we'll need to keep track of how many coins the player collects. So let's use a collected coins variable to store it, and set it at the beginning of the init game method. Each time a coin is collected, we increase this variable by 1. Next, you'll need the game to end when the hero hits obstacles. So let's invoke the game over method, which we're now going to define. Define a new method called game over. Reset the game and initialize the game again inside the method. Then you need to define the reset game method. There are several things that we need to reset. The first one is the listener inside the ticker. You'll then want to remove all the game objects from the camera. We'll now reset the camera's position to 0. You can now reset the game every time we call the init game method. We also want the game to be over when the hero falls off a platform. Hence, we'll add the hero position check inside the move game object method. If the hero's Y position is greater than 500, we reset the game. Save all your files and test the game in a browser. This time you can collect the coins and the game resets when the hero hits obstacles or falls off a platform. You'll have to play the game carefully now. We've almost wrapped up the game with a reward and game over mechanism. You'll now be able to apply different effects to the game when the hero collides with different types of game objects. In the next section, we're going to apply static graphics and sprite animation to your game. Welcome back to Pact Publishing's HTML5 game development video tutorial. So far we've made the game playable, but all the game objects are still represented by rectangular shapes. In this section we're going to create and apply graphics to your game. There'll be static graphics and sprite animations. We'll see how to turn an animation sequence into frames, which we can use in the easel.js game, and we'll also create a preloading scene as we progress. Let's get started. You've now got a working game with some basic moving rectangles to represent your game's elements. We'll now prepare animated and static graphics for the game's objects to improve its aesthetics. Let's see how. We'll first animate the coin to create a rotation illusion. The obstacle will be a rotating saw with sharp teeth, and our hero will have a running animation. Besides these three animated objects, all the others are static. Initially, we'll work on the static graphics, so let's draw the background and platform. According to our canvas tag, the background dimensions are 480 by 320 pixels, which are the same as the stage. For the platform, we'll use the dimensions 120 by 12 pixels. Later, we'll see how you can make the platform graphics work with dynamic width. We'll then need animation for the game coins, obstacles and hero, something we'll draw in Adobe Flash. The final animation graphics look like this. It's several frames put together from left to right. Easel.js provides us with a function to set the width and height of one frame. Here we have 10 by 10, and display each frame periodically. We'll export the Flash animation to a sprite sheet using the Zoe tool from the same creator of Easel.js. This tool reads a Flash-generated SWF animation and exports both sprite sheets graphics and a JavaScript string, which we can directly use in the Easel.js-based game. We can open our SWF animated file by dragging it in the tool, then switch to the Settings tab. The setting on the extreme left is the padding on each frame, and we need to get rid of it, so let's see it set to 0. The second setting is scaling. Since Flash documents are vector-based, they allow us to scale graphics before exporting. The current size is fine, so let's keep it 1 without scaling. It's easier to control the animation with a fixed dimension boundary, so we'll turn off the variable frame option. The slider to the extreme right allows us to reuse duplicated frames to make output graphics in a smaller file size. The bottom controls are only for previewing and do not have any effects on the output files. In the Export tab, you'll want to ensure that the trim option is on, and leave the other options as they are. Let's click on the Export button and we'll get a summary dialog. It tells us where the output files are placed. Usually one PNG file and one JSON file is generated. You'll need both the PNG and JSON files, so let's copy them to the image directory of our game. Finally, let's do the same for the obstacles and hero. It should look like this. In this video, we've concluded some basic game object graphics preparation. You can now transform an animation into a sprite sheet. In the next video, we're going to see how to apply static graphics to the game. We've prepared some graphics so far, but you've probably realised that we haven't integrated the files into the game yet. In this video, we're going to add static graphics to the game. Let's see how. We'll begin by drawing the background. Our background is independent of the camera movement, so let's add the graphics to the stage just before creating our camera. Switch to the constructor of the rush-game.js file, then create a container reference and put a bitmap image of the background trees.png inside it, and thus we add a background to the stage. It's important that we add the background to the stage prior to adding the camera because the latter added child will be in front. We'll then add the platform graphics to the game, so let's open the rush-platform.js file. Remove the original shape drawing code and replace it with a bitmap instance of the platform.png file. Let's save the file and open our game in a web browser. We have the static graphics integrated successfully. We've taken our graphics and put the static ones in the game. You'll now be able to add graphics to the game that's either independent of the camera movement or moved along with the camera. In the next video, we're going to see how to integrate sprite sheet animations into the animated game object. You've now got a part of your graphics integrated into the game. However, sprite sheet animation is still pending. This will be relatively simple using the Zoe exporting tool and the bitmap animation class from the Create.js. Let's see how. Let's work on the coins first. Open the rush-coin.js file. Let's get rid of the original shape drawing code as we don't need it anymore. Before you write the animation code, let's take a look at the sprite sheet class. The sprite sheet class controls animation and the frame's meta information of the graphic file. There are three major properties: image files, frames data, and animation sequences. It's a large block of data and you could easily get lost. Fortunately, Zoe already generates this data for us. This tool generates two files for us, a PNG and a JSON file. The JSON file contains the sprite sheet data that we need. You'll then need to copy the contents inside the coin.json, so open the file in any text editor. Let's copy all the content and then paste it in our source code with a variable referencing it. It fits our need almost perfectly. You just need to modify two things. The first modification is the image path. Place your image inside the images folder. You'll need to update the path of the sprite sheet class. The second modification is optional. Our current animation has only 5 frames, so it'll be flickering very fast under 40 frames per second. You'd probably like to slow down the animation. This can be done by adding one more property to the all animation, which is the frequency property. The frequency denotes how frequent the ticker advances this animation to the next frame. The higher the frequency, the slower the animation plays. We'll set the frequency to 10 in this example. We'll then pass our well-constructed data to the sprite sheet class and create the bitmap animation instance from the sprite sheet class. Our sprite sheet image can contain frames of multiple animations. The default animation is named all. You'll then want to play your animation, so we'll tell the animation instance to play the all animation using the goTo and play method. Finally, add the playing animation to the coin container. Let's save the file and test our coin animation in the browser. The coins are now animated perfectly. Apply the same steps to animating your hero and obstacles. Let's move to the rush-obstacle.js file. Similar to what we did for the coin, remove the shape drawing code, then copy the content from the obstacle.json file and place it as a variable. Make sure that we update the image path. We want to slow down the animation by setting the frequency property. Then we'll apply the same steps on the hero, so we switch to the rush-hero.js file using the same code approach. Let's save the files again and check our animations in the browser. Everything looks good now. We've taken the static graphics game and ended with 3 animated game objects. You'll now be able to use the sprite sheet data and display them as animations in the game. In the next video, we're going to see how we can make the platform graphics with dynamic width. So far we've added some graphics and animations to the Rush game. One thing we disabled is the variable width on the platform. You can easily adjust the platform graphics by using a sliding door effect. Let's see how. The sliding door approach is done by splitting the platform graphics into 3 pieces: left, middle and right. The left and right pieces of graphics are stuck to both edges, and the middle piece of the platform will only have 1 pixel width. We then scale the middle piece to fill the gap. We'll export and name them as platform-middle.png and platform-right.png. We want the middle piece of graphics scaling smoothly, so we'll choose a segment that does not have the noise feature. Else you'll have a scaled platform effect, which doesn't look good. It's time to add some code. Let's switch to the rush-platform.js file. We'll use the original platform graphic code if the width is exactly 120 pixels. When the width is larger than this, we use our new approach. Initially, add the 3 pieces of platform graphics with the variable referencing them. You'll then need to place them in the correct positions. The left platform doesn't need position adjustments because the default is 0, 0. The middle graphic is placed with the X value equal to the left platform's width, which is 57 pixels wide here. We'll then use the middle piece to fill in the gap. So let's scale the X value. The original width is 1 pixel, and we use the scale X method to scale it. The scale value is given total width minus the left and right platform's width. It's then time for the right piece of platform. The X position of the right one is the X position plus the final width of the middle one. Finally, we'll use a variable width while creating platforms. So let's switch to the rush-game.js file where we create platforms in a for loop. Since our logic now only handles a width that is greater or equal to 120, the minimum value is 120 and we'll have some more random pixels added to it. Save your file and test the new platform code in the browser. The platform has a slightly different width now. We've taken the platform's graphics and concluded with a variable width platform. You'll now be able to create game objects with variable dimensions of graphics. In the next video, we're going to see how to create a preloader with the progress of our Rush game. By now, you've got all the essential graphics ready. The game works perfectly on localhost. However, if you test the game on a slow internet connection, you'll probably find that the game takes some time to load, especially the graphics files. We discussed how to preload graphics in our first game example. Right now, we only have light graphics and no loading progress bar. Fortunately, we can reuse our previous preloading logic and improve it with a loading screen. Let's see how. Initially, we'll reuse the preloader logic that we use in the Count 99 game. So we'll create a new file and copy the preloader class from the previous game example to this file. Save the file with the file name rush-preloader.js. You'll need to modify several things in the copied code. You'll first need the class to be under the same namespace, so change the C99 namespace to Rush. Next, find a list of image paths and names at the beginning of the load graphics method. We'll update this list to reflect our image files. So let's update it. We'll now need this preloader class to visualize the progress. Let's use a black background and a grey progress bar, which acts as an indicator that will display the progress from left to right. We'll also have some text displaying a percentage. Extend the preloader class from the create.js container. You'll then need to initialize the game graphics in the preloader constructor. Draw a black background, a grey progress bar, and a text aligned at the center. You'll then need to update this progress bar's graphics while loading files, so we'll define a new method named updateProgress. Inside it, draw a grey rectangle with the width based on the percentage. Also update the text indicator here, and then invoke this updateProgress method on each loaded file and remove the preloader graphics on completion. Finally, we'll use our preloader class in the game logic, so switch to the rush-game.js file. Replace the reset and init game at the end of the constructor with the preload, initialize and loading graphics methods. We can call reset game at the beginning of the init game method to ensure that the game is reset every time it's initialized. And make sure you include any new JavaScript file in the index.html document. Let's save our files and test our game in a browser. In order to simulate the game running on a slow connection, I'm using a tiny Java application called Sloppy that can simulate our local host with specific connection speeds. The grey progress bar should move from the left to the right. We've figured out the game and concluded with a graphics preloader. You'll now be able to track load progress and depict it visually on your canvas. In the next section, we're going to see how we can add a main menu and game over scene to the game, as well as a high score leaderboard. Welcome back to Pact Publishing's HTML5 game development video tutorial. In this section, we're going to complete our game with a menu and game over scene. We'll save the highest score of the player and have a leaderboard for several top scores in the past. Finally, we'll complete the game with a basic website so the game is ready to be deployed to a web server. Let's get started. Now that you've got the game running with graphics and a loading progress bar, the next logical step is to add a main menu. A player should be able to choose when the game starts, instead of it just being outright. Adding one is as simple as using an HTML div overlay on the game as the menu scene. Let's see how. You'll first need some graphics to represent the menu scene. The dimensions of the game are 480 by 320 pixels. You'll need a specific graphic for your scene. You'll then need to have a DOM element overlay on top of the game, so add a div inside the game section after the canvas tag. We put it after the canvas tag so it'll be out in front of the game by default in case these two elements overlap. Name this div with an ID menu and a scene class, which we'll share between the menu scene and game over scene. By default, we'll hide the game over scene so that the player can see the preloader. Add a class called hidden and make it invisible in the CSS style. You'll need a trigger to start the game in the menu, so let's add an anchor href with an ID start-btn. We're going to let the player click on any point on the menu scene to start the game, so you need not put any content in this anchor link. We'll handle that using CSS. Before we get into the logic, you'll need the anchor button to have the same dimensions as the menu scene and the game, so let's define our CSS style. The scene shares the same dimensions as the canvas and uses the absolute position with top 0 and left 0 to place it in front of the canvas. As the scene class has an absolute position, you need to set its parent element and the game with a relative position. You'll also have a hidden style to quickly toggle the visibility of the scene. For a menu scene, we'll use a simple background image. It's now time to look at the start button. The anchor link has an inline behavior by default, so set the display to block and give it the same dimensions as your scene. That's all for the styling. Let's move on to the JavaScript logic. You need to listen for the start button click, so we'll need a logic for the same in the game.js file. Inside the window.onloadHandler function, we'll listen to the onClick event. While it's clicked, hide the menu scene by adding the hidden class to the class list, and then initialize the game. One more thing that needs to be considered before we're done, a preloading scene, which is displayed inside the canvas stage. That's why we had the menu scene hidden at the beginning. However, you'll need to show the menu scene again after all resources are loaded. So we remove the hidden class of the menu scene in the preloader class when the loading is complete. Let's save the files and test our menu scene in a browser. I'll simulate a slow load with sloppy again. You should see a loading scene appear, followed by the menu scene. You can click anywhere on the menu scene to start the game. We've taken the game logic so far and concluded with a menu scene before the game starts. You'll now be able to add a div-based scene outside the core canvas-based game. In the next video, we'll see how to display a game over scene after the player dies, and we'll use it to display a high score as well. You've now got a main menu set up for your game. All that remains is a game over scene with a restart button. Let's get started. Initially, you'll need to prepare the graphics of the game over scene. An image with game over and a sentence telling the player to restart the game by clicking anywhere on the screen. The image is placed inside the images folder. You then need to add it to the game, so we'll add a div with an ID game over in the index.html document. This div has a scene class as well as a hidden class, and we'll add it after the menu scene. We'll also have an anchor inside the scene for restarting the game. The HTML edition is complete, and we now need to add the background to your game over scene. Open the CSS file. Since we have all the scene styles defined already, the game over div has only one background style pointing to our graphic. The restart button shares the exact same styles of the start button in the menu scene, so we can just add the restart button to the selector list with a comma separating them. You'll then want to display the game over scene, so let's switch over to the rush-game.js file where we originally reset our game in the game over method. Replace the game reset command to this code that displays the game over scene by removing the hidden class. Finally, we need to listen to the restart button event after the scene shows up. So add your button handling logic to the game.js file. We add the logic in this file because the game's flow is not related to the rush game logic, so we do not place it inside the rush-game.js file. When the restart game button is clicked, we add the hidden class to the game over scene so that the scene disappears and the canvas game is visible. And you can call the initGame method here to initialize as well as restart your game. Let's test our game in a browser and see how the game over scene works. You'll initially see a menu scene, then the game starts, and the game over scene appears when the hero dies. We've begun with the menu scene game logic and concluded with the game over scene. You'll now be able to manage and toggle multiple scenes in your game flow. In the next video, we're going to see how to display a high score in the game over scene by saving the scores into the local storage session. You've now got a game over scene, but we've got plenty of empty space in it. We can use this space to display the highest scores your players have achieved. We'll use local storage to save the score each time and display the highest score here. Let's see how. Initially, you'll want to let players know the score they get during their game, so we'll add a div overlay to display it. Place it after the canvas tag and before the menu scene. Then you'll need an element to display the final score and best score in the game over scene. So add one more tag inside the game over scene with the ID defined as your-game-score. Next, place the two elements in their correct places by styling using some CSS. Let's display the score on the upper left corner. We'll use an absolute position and place it on the top left side with some margin. The final score ought to be at the centre of the game over scene, just below the game over message. So it has a top value of 90 pixels. You'll need some spaces for the leaderboard in the next section, so don't place it too low on your screen. That's all you'll need to know regarding the graphics for this part of the video. Let's move on to some JavaScript logic in the rush-game.js file. You'll need to display the scores continuously during the game, so we better reference this element in the initial stage. You'll need to display the number of collected game coins at the score continually. For that, let's use the collected coins variable inside the update view. We then need to display the final score in a game over scene, so update the your-score element inside the game over method. Finally, you'll need to display the highest score. So let's use the concept of local storage here. Local storage allows us to save data into the client's web browser in the key value pair format. The data persists even when a browser session ends. Normally, browsers allow 5 megabytes of data per domain, and all we need now is a few bytes. In a supported browser, you can use local storage just like you would in an array. Load the highest score value from local storage and set it to 0 in case it's the first game. Then compare the current score with the highest score that's saved. After the comparison, save your new highest score to the local storage. Finally, display the highest score inside the game over scene. It's time to save all your files and test the high score mechanism. You'll need to play several times in order to see the feature working. Try getting a low score in the first game, a very high score in the second game, and then random scores in later games so that we know if you can beat your highest scores. We've concluded our rush game with the high score mechanism in this video. You'll now be able to save and retrieve data into the client's web browser by using local storage. In the next video, we're going to see how to enhance the scoring system by displaying a scoreboard with several high scores. By now, you've managed to display the highest score in your game. The next logical step is displaying more of them using a scoreboard. It's as simple as saving an array of high scores and displaying it on a leaderboard. Let's see how. You'll first need a container for the leaderboard, so we'll define an element with the top-scores ID inside the game over scene. You'll then need a dedicated class for the top scores module because the logic becomes more complicated now. Create a new file named rush-topscores.js inside the new file. We have defined a basic class with the name topscores. You'll need 2 instance methods, saveScore and toHTML. The saveScore method will be used to save the given scores to local storage with a sorting from high to low in a hierarchy. The toHTML method will let us use an HTML representation of the high scores leaderboard. We need to implement the core method first, so let's work on the saveScore method. The argument in this method is the score that we're going to save to the list. Use an array named scores to store the score history. The scores are part of an object named data. We put scores under the data object in case we need to store more data in the future. Then we want the score history to be sorted from the highest to the lowest values. So sort in the descending order. After sorting, we need to trim the array in order to retain only the top several scores and prevent the array from growing into a long list. We'll use the slice method to retrieve the first 8 records and then save data to objects with the scores as string values in local storage. We'll calculate our scores in an array using JSON, the JavaScript object notation, to store the entire array as a string. We'll use the JSON.stringify function to convert the data object into a JSON string and save it in the local storage with the key scores. You'll then need to initialize the module by loading scores from local storage and setting up the data object, so we'll work on the constructor. If you have a previously saved scores list, use the JSON.parse function to convert the JSON string back into the JavaScript object and arrays format. Otherwise, we'll create an empty array. You'll then want to display the scores history in HTML, so let's implement the toHTML method. This is a list of records, so we'll use an unordered list. It's a simple loop that lists the records into the list item. That's all for the topscores class. Next up, using the this class, include the classes file in your HTML file. Then, when the game is over, we use the topscores class and save a new score with the collected coins from the game. We then display the scores history in the topscores element of the game over scene. You'll then need to add some styles to the scores leaderboard, so let's switch to the CSS file. Reset the style list and padding and align it along the centre of the scene. Finally, we want to pause the main loop of the game when the game's over. This prevents the game from running endlessly when the game over method is called. Set the ticker pause to true in the game over method. We'll unpause the main ticker after the player clicks on the restart game button. Let's save all the files and test our game in a browser. While the hero dies, you'll not only see your current score, but also a history of top scores. It'll motivate players to keep coming back and trying their luck at beating the high score. In this video, we've modified our previous score tracking mechanism and created a simple leaderboard. You'll now be able to apply the concept of local storage to store objects and arrays. In the next video, we're going to see how to decorate the game page by using simple HTML and CSS layout. By now, you've nearly completed your game and it's almost ready to publish. However, you'll probably find that our web page contains just one game without any decorations. Fortunately, you can use some simple HTML and CSS layout techniques to quickly give your game some finishing touches. Let's see how. Here's a preview of what we're going to end up with. You'll first need to prepare some graphic images for our layout, so let's draw these graphics. There's one big banner for the title, a blue sky background with a mountain landscape, a subtle grey background image, a horizontal rule image, and one coin image for the list item. You then need to build a website layout, so we'll work on the index.html document. Place a header right after the body begins. We'll leave the entire game element unmodified. Then, after our rush game, we'll set up a 2-column section. On the left, we'll display a How to Play guide, and on the right, we display the scores leaderboard. At the bottom of the page, we'll have a horizontal rule and a footer section. You'll then need some JavaScript to retrieve scores to display on the leaderboard of your web page. Let's switch to the game.js file. Inside the window.onload handler, we use the top scores class from the last section and display the HTML list of scores in the scores board. Your HTML and JavaScript is ready now. Finally, you'll need some styles while putting the images and elements together, so we'll switch to the CSS file. Set the grey noise image to be the default background of the HTML element. We'd like to have a mountain landscape with a blue sky on top of the page, so let's put a landscape in the body tag background with the repeat X value. You'll then need to apply a background to the header tag and hide the H1 text when CSS is available. This is because our header image already includes the game title, and the heading 1 text is only there in case the style's not applied. The game itself is fine, but you could add a border to your game and a subtle shadow at the bottom. We'll then have a row with 2 columns, so you'll now have a row class that's 480 pixels in width and aligned to the centre with the left and right margin set to auto. The overflow auto is used for calculating the floating children elements correctly. The 2 columns have a class named half, so their width is 50% while the value for float is left. You'll then need 2 lists. We'll define the list style to be a little coin image, and we have a horizontal rule before the footer. I've already prepared an image for that, similar to heading 1 in the heading section. We hide the HR element when styling is applied. Finally, we make our footer a softer text colour and decrease its size. Let's confirm that all your files are saved and refresh your game. Let's confirm that all your files are saved and refresh your game in the browser. As you can see, the game looks much more pleasing to the eye and far more suitable to publish. Your game is now ready for others to play.